So today's lesson is all about flooding, but how do we actually know if a flood is going to happen? So have a look at these pictures. Think, well, how do we know? How do we know when it's going to flood? Right, so we know because we can look at rainfall. That's what this thing here does. This is a radar. It shows us where the rain is. We can also model flooding. So this is Calverton. This shows you in blue the areas where the stream is and where it might flood. We can predict, so we can issue weather warnings based on the weather forecasts and then issue flood warnings if we think people need to get out of the way. And then the final thing is this thing here, which is called a hydrograph. And that's what today is all about. So hydrographs, ultimately we've got to look at what they are, what they show, what changes them, and then make some judgments about what has the most impact on changing the shape of those hydrographs. So final section here, river management. We're here looking at hydrographs. Once we've done today, we'll start looking at how we manage flooding through hard and soft engineering. So it's the use of hydrographs to show the relationship between precipitation and, oh, sorry, typo, I should say discharge. So this is your hydrograph. This is what it shows. And it's two graphs, I suppose, that show the amount of rainfall, and that's your bar chart. So you see here, these blue bars, that shows you the amount of rain or snow or sleet, we call it precipitation because it covers everything, and when it fell. So for example, you can see this first bar here, this fell between 9 and 10 a.m. in the morning. This amount fell between 10 and 11 a.m., 11 and 12 a.m., and then into the afternoon. So the way I remember that is I think of glasses of water or bottles of water. It's blue, bars, bottles of water. Same as what we've done on a climate graph before. And that rainfall, that has its own axis. So you can see it's this one here, the blue one, it says rainfall in millimetres. A lot of the time, you'll actually have an axis on either side of the graph. So just make sure that you always look at the one that's talking about rainfall or precipitation. And where you have your highest amount of rainfall, we call that the peak rainfall. Not hard to remember, it's where rainfall reaches its highest, the peak rainfall. The other graph on here is the line graph, and that shows you the discharge. So it's showing you the amount of water in the river. So as a river fills up, starts to flow faster, its discharge becomes larger. And we measure discharge in meters cubed per second because it's the amount of water, the meters cubed, and how fast it's moving, so per second. And as that line graph goes up, you can see the discharge of the river from these normal levels down here, all the way up to its peak discharge. And that's when the water in that river is at its highest. And if it's going to flood, that's when the flood is most likely. And you read that on the discharge axis, measured in meters cubed per second or QMEX. And like I said, sometimes you'll have the rainfall scale on this side and the discharge on this side. You just have to make sure you double check and you're reading against the right one. So there's a few other labels on there. As your discharge rises, we call that the rising limb. So the amount of water the discharge is rising limb. When it reaches its highest point, its peak, we call it peak discharge. And the time between your peak rainfall and your peak discharge is called the lag time. And you'd usually report that in hours. So look at that. Peak rainfall was at 12, peak discharge was at 8. So the lag time there is 8 hours, the difference between 12 and 8. As your discharge starts to fall, we call that the falling limb. And then eventually the amount of water in your river will get back to those normal flows, those base flows. And that's just what your river would be like under normal conditions. So all it is, it's two graphs really on one that shows the changes in rainfall, well, precipitation, and river discharge over time. And it's important because it shows us that lag time and it shows us how quickly water in the river increases. And if the difference between the rainfall and the discharge is short, the rising limb is high or steep, it means it's likely to flood. So rivers that have a hydrograph like this, short time between them, they're likely to flood. If a hydrograph had, say, I don't know, 12, 14 hours between the peak rainfall and the peak discharge, and quite a low peak discharge, it would be less likely to flood. And those factors we looked at last lesson, so the physical and human factors, deforestation, agriculture, intensity of rain, they affect how quickly water gets into the river. So if you chop down all the trees in an area and you have a really heavy rainstorm, you're going to actually shorten the lag time. That water, the rain, is going to get in the river much quicker and increase the risk of flooding. And that's why these things are quite useful. So we're going to have a go at creating our own. If you've got some graph paper, please use graph paper. If you don't have graph paper, you'll just have to do it on plain paper, but make sure that you use a ruler and you use a pencil. So this is your template. On the left, you've got your rainfall, which is in millimetres, and that starts at 0 and it goes up in 5s all the way up to 70. On the right, you've got your discharge in cumex, or metres cubed per second, and that starts at 0 and it goes up to 140. It's important that you realise that they're different, and I'll talk you through how you plot it in a moment. So this box here, this shows you the amount of rain. So in that first hour between 0 and 1, you'll notice this is in time and hours, not time as in 7 a.m, 8 a.m, 9 a.m, etc. So in that first hour, the rainfall was 10 millimetres. So what you can do is you'll draw your bar chart here, up to 10, with a ruler, with a pencil. There you go. Second hour, third hour, fourth hour, fifth hour, sixth hour, all the way up till it's 5 millimetres. Yep, so that's what your bar chart would look like. It doesn't matter if the bars touch each other. It was just easy for me to plot it that way. So that's what your rainfall looks like. Now I'm going to look at discharge. So this is this box here. And you've got your times, but look, we've got it every 2 hours. So it means you plot at 0, 2, 4, 6, 8. And make sure you use this scale here, this one on the right. So sometimes what I like to do is I put something over the scale on the left so I ignore it, like a ruler or pencil case or something. So at 0 hours, the discharge was 30. So there's 0 hours, there's 30. So I'll put a little X here. At 2 hours, it was 35. So that's going to be here between 30 and 40, put a little X here. So on until it looks something like this. And with your discharge, you just connect those lines, those dots to make a ruler, with a ruler to make a line. So they can see I've got my rainfall, I've got my discharge. Once you've plotted all of that, I want you to label it with these. So where's the peak rainfall and the hour of greatest rainfall? Where's the peak discharge, the lag time, the falling limb, normal flow, rising limb? I'll upload this PowerPoint to show my homework as well, so you can actually have that open. You can have a look at the labels on this one to help you. So you can label yours. Once you've done all that labelling, I want you to have a go at these questions. So what is the peak discharge in millimetres? What's the peak rainfall? What's the total amount of rain that fell in this rainfall event? So you need to add up all of those values over the 6 hour period. How many hours was the lag time? So between peak discharge, between peak rainfall and peak discharge. And study the hydrograph you've drawn. Would you say it's a flashy hydrograph? So is it a hydrograph that's happened during a storm that's responded very quickly, or would you say it's a slow response hydrograph? So one that's responded very slowly, and you need to explain why. As a challenge, I want you to link this back to what we did last lesson. So what conditions do you think may have affected the shape of that hydrograph? So if you think it's a flashy hydrograph, a hydrograph that's responded very quickly, well, why? Is it because of heavy rain or urbanisation or deforestation or something? But I do want you to explain your reasons for that. So that should take you quite a while. That's the main task. That's the only task really for today. Last thing is you're just going to have a look at 2 different hydrographs and you're going to spot the difference. So I would like to write this as a comment for me on Show My Homework, just so I can check your understanding of hydrographs and what they show. So in what ways are those two hydrographs different? Remember, use the key terms: rising limb, falling limb, peak discharge, peak rainfall, lag time, flashy, slow response. So in what ways are they different? For example, does one of them have a shorter lag time? And then why are they different? So why is this on the left a different shape to this one on the right? Okay, that's it for today. There is a spelling test for you to have a go on, just based on some of those key terms. And then we'll look at how we stop flooding next lesson. Okay, take care. Bye-bye.